Hello everyone, and welcome to our second part on Lewis structures of molecules and polyatomic ions. Today our focus will be focusing more on polyatomic ions, as well as learning how to draw double, triple, and single bonds for molecules that need them. So let's start today with this molecule here. We're going to start with Nh4 Plus. So, as always, the first step is to determine the number of valence electrons. We see here that nitrogen is in the fifth group, so it has 5 valence electrons. And hydrogen, we have 4 of them, each have 1. So we can add 4 and we get 9 valence electrons. Now this is an odd number, so here when we get to step 2, it'll be difficult to find pairs. However, make sure you remember that this is Nh4 plus. And when you have a cation, you always want to remove one electron. So we come up with 8 valence electrons. So now that we've found out the number of valence electrons, let's determine the number of pairs we have. As always, we just take these 8 valence electrons and we divide them by 2, and we get 4 valence electron pairs. Now for step 3, we want to see what the central atom is and how we can surround it with an octet of electrons. So for this molecule, it's going to obviously be hydrogen, and this is because, nitrogen, and this is because hydrogen can only make one pair or one bond with any particular atom. So we'll start out with nitrogen here as our central atom, and we know we have to have 4 pairs, and we have 4 hydrogens. So let's just go ahead and draw the hydrogens outside, and we go, okay, there's 1 here, and there's 1 pair here, 1 pair here, 1 pair here, and as always, we go ahead and count 1, 2, 3, 4, so this checks out. And something you need to know when you draw polyatomic ions is I always like to write these brackets to the outside to denote that this is not a neutral atom and that there is a positive or negative charge if that applies. Let's go ahead and go on to carbon monoxide. So we have CO. We know that carbon has 4 electrons because it's in group 4, and oxygen has 6 electrons, 6 valence electrons because it is in group 6. That gives us 10 valence electrons that need to be accounted for in the Lewis structure of carbon monoxide. Let's go ahead and find out how many valence electron pairs we have. Just divide it by 2. We have 5 valence electron pairs we need to make sure we account for. So step 3 really doesn't apply to this one, as it's not like it's just two atoms in this molecule, so it's not like we have a center that the other one's attached to. So let's just go ahead and write C and O. So we're used to just drawing a single bond between these two, and then we see, oh, well, we have 5 valence electron pairs, and we just got rid of 1, so we have 4 left. So if we wanted to, we would just draw these pairs here. But then what we notice is these atoms are not filling their octet of electrons, because carbon likes to have 4 pairs, and they all like to have 4 pairs of electrons around them. But here, carbon only has 1, 2, 3, and same with oxygen, only has 1, 2, 3. So this is not what we want here. This is not going to fulfill the octet, so we need to try to figure out a different way to draw carbon monoxide. So this introduces us to the idea of double and triple bonds. Basically, to put it simply, it's just drawing multiple bonds between a carbon and an oxygen. So we could just draw, here we have carbon, oxygen. If we wanted to just draw 1, 2, 3, this is still 3 pairs of electrons here. But what this does is it makes sure that carbon and oxygen both obey their octet rule. So let's go back to our pairs. We need 5, but we only have 3 here. So let's just add a lone pair here, a lone pair here. And here we're all good. We have carbon has 1, 2, 3, 4 pairs that obeys its octet. Oxygen has 1, 2, 3, 4 pairs, which obeys its octet. So that means we are all done with carbon monoxide. And then let's go on to our last and final molecule here, C2H4. So we know that carbon has 4, as we said before, but that'll be times 2 because we have 2 of them. And we have 4 hydrogens, each giving up 1, which gives us 8 plus 4, 12 valence electrons. And we go down here and we find our number of valence electron pairs. We have 6 pairs. So for this one, we will also have to employ the idea of double and triple bonds. So let's just draw this. So we always know, by the way, that carbon is a central atom, which is something we mentioned in part 1. If you want to go back to that video and learn why that is, you feel free to do so. So we know that carbon is going to be here. It's going to be in the center of the molecule. So let's just already draw one between each carbon. And we have hydrogens on the outside here. Hydrogens can only make 1 bond, so we'll just hit each one with 1. So again, we have to make sure we have 6 pairs. Here we have 1, 2, 3, 4, 5. And kind of on top of that, which should also be another telltale sign that you need to try to use double and triple bonds here, is that carbon has not obeyed its octet. Currently, carbon only has 1, 2, 3 bonds and pairs of electrons surrounding it when it would prefer to have 4. So again, we will employ this idea of a double and triple bond. We still have 1 to account for, so we can feel free to draw another bond between the carbons. And this way, what we ensure is that we have 1, 2, 3, 4, 5, 6 pairs of electrons, as well as carbon having the octet that it desires. We have 1 here, 1 here, 1 here, 1 here. That's 4 pairs or 8 electrons obeying the octet rule. This is a symmetrical molecule, so it also applies to the second carbon. Now, something I'd like you guys to do for practice is go ahead and try to draw the Lewis structure for water, H2O. This will also use the idea of making sure you have the octet rule obeyed. And let's also go ahead and try the molecule for SO3. This will also try to employ the triple and double bonds. And once you guys go ahead and draw these structures, you could just go into Google them, and the structure should pop up so you can check your work. Let us know if you guys have any questions, as well as future videos you guys would like to see. Thanks for watching.